Research programs can be split up into two broad categories. In experiments or experimental studies, the researchers make controlled changes to a single variable, then measure the response variable looking for changes. Medical studies, for example, where drugs are administered in different doses are an example of this kind of approach. Observational studies, on the other hand, are based purely on observation. Now, this can be done in real time with live participants or historically, right, by looking at things like census data. So I've got some examples here, and I want you to take a minute and see if you can classify each one as either observational or experimental. So in the first scenario, the researchers are going back and looking at historical records. They aren't actually interacting with the participants. For example, they aren't giving people ice cream and sending them out for a swim to see what happens. So this is an example of an observational study. Now, in the second scenario, the researchers are actually interacting with the participants. They've made a change to the participants' behavior and environment by specifying exercises they should do and the foods that they should eat. So that puts this scenario into the experimental category. Now, our third scenario is also observational. So you can make an argument that just by interacting with the participants, the researchers have potentially influenced their behavior. And that's a valid point, and it's something the researchers have to be aware of. For example, when they're writing questions, they have to be very careful to phrase them in such a way that they don't accidentally influence the responses. However, this still belongs in the observational category, since there was no explicit intent to influence the responses, and in a well-designed study, the researchers would have taken steps to minimize any incidental influence. So the goal of many research studies is to show a correlation between two variables, but this is often a high hurdle to make. A key point to keep in mind is that correlation by itself doesn't imply causation. In other words, just because two variables are linked to each other, like the ice cream consumption and drowning deaths in the first scenario, that doesn't automatically mean that one is causing the other. In general, the only way to show causation is going to be through an experimental study where the researchers are explicitly controlling both the variables in the study and any potential confounding variables that could affect their results. Okay, so why would you want to conduct observational research at all then? Well, there are several reasons. One is that you're explicitly looking to see changes over time. Right? Long-term studies are expensive and challenging to conduct, so looking back at historical data is sometimes more practical. Another reason is that it could be unethical to look for the results you're looking for experimentally. For example, think again about my ice cream example. To show causation, you would have to do what I suggested on the last slide. Give people ice cream, then send them off to swim, with the plan being to see how many of them drown. Obviously, that's not acceptable. So that would be another situation where an observational study would be a practical alternative. So in the next two lectures, we're going to go deeper into this distinction by looking at specific types of observational experimental studies and talking about the strengths and weaknesses of each one.